Tell me about a data science project you are proud of. Imagine turning 1 million rows of messy hospital data into a prediction engine that could save millions in reimbursements. That's exactly what I did. In one of my most impactful projects, I built a machine learning model to predict healthcare reimbursements using historical claims data. The dataset was noisy and complex, but I cleaned, engineered features, and tested several models, including XGBoost and Random Forest. The final model improved prediction accuracy by 18% over the previous baseline. I also created a dashboard to make the insights actionable for non technical stakeholders. What made it special was not just the technical success, but its potential to drive cost saving healthcare policies. How do you handle missing or corrupted data in a data set? Based on how you answer this question, they will evaluate your experience in handling data sets. So, answer this way. To me, missing data is like a puzzle. It's not just something to fix, it's something to understand. The first thing I do is to investigate the pattern of missingness, whether it's MCAR. Missingness is unrelated to any data, observed or unobserved. MAR, the missingness is related to observed data but not to the missing data itself. Or MNAR, the missingness is related to the missing value itself. I visualize it using heat maps and missing value metrics. For numerical data, I might use mean or median imputation or predictive models like KNN or regression. For categorical variables, mode imputation or a separate category often works. If missingness is too high, I consider dropping the feature. I once worked on a patient records data set with 40% missing BMI data. We used predictive imputation based on age, gender, and medical history, which preserved both accuracy and data integrity. This is how you should answer this question. Think of agentic AI as having its own goals and AI agents as tools built to achieve your goals. Agentic AI refers to systems that can set their own objectives, make decisions, and act with autonomy to pursue those goals, almost like having an independent sense of purpose. These systems exhibit planning, reflection, and adaptability, often beyond narrow tasks. In contrast, AI agents are goal directed tools designed to complete specific tasks set by humans. They may have autonomy in execution, like a chatbot that books flights, but the objectives come from the user, not the AI itself. For example, an AI agent might help schedule meetings based on your calendar, but an agentic AI could analyze your workflow, notice inefficiency, and decide to automate repetitive paths without being explicitly told to do so. How do you choose the right evaluation metric for a model? Choosing the right metric is like choosing the right lens. It shapes how you see the model's success. I always start by asking what is the business goal? For imbalanced classification tasks like fraud detection, accuracy is not enough. I look at precision, recall, and FN score. In regression, RMSE and MAE are common. But if we care more about percentage errors, I use MAPE. I also check AUC ROC curve for binary classifiers. For instance, in my healthcare reimbursement project, minimizing RMSE was critical, but we also used R square to measure explanatory power. Choosing the wrong metric can give a false sense of model performance. So context is everything. What is your approach to feature engineering? To me, feature engineering is where the art of data science really begins. It's how you teach the model to think. My approach starts with understanding the domain. Context shapes features. I explore the data, look for outliers, schemeness, and variable interactions. I create new features based on domain logic, time variables, and categorical transformation. For example, in an e commerce data set, I created a purchase to visit ratio that significantly boosted model performance. I also use techniques like binning, one hot encoding, polynomial features, and embeddings when appropriate. Good feature engineering often makes more difference than tuning hyperparameters.